In this brief presentation, I'd like to demonstrate and discuss example 2 in the textbook, where they demonstrated the dependent t-test, 2 paired observations, using the Iowa Self-Assessment Inventory to look at the differences in the means on 2 subscales of the measure, the emotional balance and the cognitive status subscales of this measure. What's interesting about this example is that it's not the typical use of the dependent sample t-test. The typical use is where we have a pre-post score situation or repeated measure situation. This is an example of where the dependency has to do with the fact that you've got a measure that is trying to provide an overall assessment of a particular dependent variable. In this case, this Iowa Self-Assessment Inventory is providing an overall assessment of elders' functioning. And it has multiple subscales within this larger measure. In this case, we're interested, the example is focusing on the emotional balance and the cognitive status subscales. So in this case, dependency has to do both conceptually as well as empirically. Conceptually, this Iowa self-assessment measure is a multidimensional measure of elders functioning with multiple subscales or multiple smaller dimensions that make up this larger dimension of elder functioning. So you've got elder functioning, which is a larger dimension, and then you've got, in this case, 2 smaller dimensions, which are represented, operationalized by 2 subscales on the larger measure. So there is both a conceptual dependency, where these 2 subscales or 2 smaller dimensions are dimensions of elder functioning, but also empirically, you've got one multidimensional measure for which these 2 subscales have been taken out of that larger measure. So you'll see that I've opened the data set, the elderly data set. The research question. The research question again, is there a statistically significant difference between levels of emotional balance and cognitive status among the elder population? How do we determine that this is a dependent sample t-test situation? Again, we have to consider the level of measurement of the variables. We have to consider, in this case, the scaling of the variables. The book talks about this in terms of the range of scores, but it's better to think about this in terms of how each of these variables are scaled. And then we have to consider other issues in terms of the distributional properties of the 2 variables. So let's first consider the level of measurement and the issue of whether these variables represent dependency when we consider this issue of using a dependent sample t-test. So again, we have this Iowa Self-Assessment Inventory, which is a multidimensional measure, has multiple items that are divided up into distinct subscales or areas. It's a rating, uses a rating scale with at least 5 points on the rating scale. A composite score is can be created for the overall score of elder functioning, and more specifically, scores for different domains or areas of functioning. In this case, our attention is on the emotional balance and the cognitive status domain. The fact that these two domains of functioning are represented or operationalized by two subscales on this larger measure creates the dependency, both conceptually and empirically, between these two measures. The other thing that must be necessary in order for us to compare those two measures is for the scaling of the two measures to be the same. They have to be on the same scale. This would require that they'd have to have the same number of items, and that the rating scales for each of the items were the same, so that the theoretical range of scores and the interpretation of the scores would be the same. In this case, higher scores representing more of, and that it also makes logical sense that these are domains for which comparisons can be made. So I think that there is an argument that these two variables that are being measured by the common instrument, the Iowa self-assessment, the emotional balance, and the cognitive status, can be compared and are representative of a situation where the two means that are generated meet the criteria of being dependent, in the same way that dependency occurs when we have pre-post observations of the same variable. But in this case, we have two variables instead of one. The next step is to look at the normality, and again, the QQ plot for each of the variables would be looked at in order to look at the normality of the variables. So we're going to descriptives, and our QQ plot, we could plug in our variables, the emotional balance, and then the cognitive status. Again, by default, the distribution will be normal that we're comparing this to. Here's our emotional balance. There are some slight departures from normality, but they don't seem to be too severe. The cognitive status, QQ plot, again, some very minor departures from normality, but again, this is a pretty good example of what a QQ plot might look like for real data when it's, for the most part, meeting that normality assumption. So let's go ahead and do our analysis. We're going to analyze. We're comparing means. We're going to the paired sample t-test situation or dependent sample t-test situation. Now we have to identify our pairs. We've got our, again, the cognitive status and the emotional balance. So it doesn't matter which one we identify first, but so we've got the emotional balance, and now we need the cognitive status variable. So that was being identified as the two pairs that are going to be compared. Again, we'll take a look at the options. The default allows us to have the 95% confidence interval, and we're fine with that. So we'll just do continue. And then we'll do OK to execute the command. All right, here's our paired results from our paired sample t-test. Basic descriptives, information, the means for each of the groups, the number of cases. Again, in a paired sample situation, the number of cases will always be equal between the variables or between the pairs. Standard deviations, standard error of measurement. You see in the paired situation, the program also generates a correlation coefficient. And again, this is nothing but a Pearson product moment correlation coefficient, showing the correlation between the two pairs, in this case between the two variables. So we have a correlation of 0.238, or you could round up to 0.24. So there appears to be a positive association between these two variables. But our real interest here is the extent to which there is a significant difference between the means of these two variables. The mean difference is about 1.5 points. Again, we can round that 1.465 to about 1.5. The standard deviation associated with that mean difference, 7.274, standard error of the mean. The upper and lower confidence interval, or the lower and upper confidence interval between that mean difference. Again, what we'd be interested in is whether that confidence interval includes 0. If it were to include 0, then we would be able to reject the null hypothesis, or fail to reject the null hypothesis, that there's no difference. In this case, the confidence interval doesn't include 0. Gets close, but it doesn't include 0. Again, when we look at the significance level associated with our t-value for the test at 98 degrees of freedom, we have a two-tailed alpha that's less than 0.05. So again, we are finding that there is a significant difference between the means, that this almost 1.5 point difference on average between those two variables is statistically significant. Overall, our interpretation is that while there appears to be a positive association between emotional balance and cognitive status, represented by the significant Pearson product moment correlation coefficient,